Okay, so we are doing transformations of linear functions for this weekly essential. And on the first two examples, we are given the function and we just need to tell what those transformations are. So for the first one, we have g of x equals negative 3 times f of x plus 1 plus 2. So remember that you want to go in order. So we're going to start with horizontal shift. And for the horizontal shift, we're looking at what's happening inside of these parentheses. It has plus 1. Remember, with the horizontal shift, it's the opposite of what it seems like it should be. So plus 1 is going to tell us to go left 1. So then next is the reflection. And for reflection, we're looking for a negative. That negative can either be attached to the x or it can be on this coefficient out in front. So if it's on the coefficient like it is, it's not attached to the x. That means that that is an x-axis reflection. For the vertical shift, we're looking for something being added or subtracted, not inside of parentheses. So this plus 2 tells us that it's going up 2. And then last one, dilation, we're looking at the coefficient. So here we have this 3. Even though it has this negative in front, all we care about is just the number itself, just the absolute value of that number, which is 3. So remember, if the number is greater than 1, that is going to be a stretch. If it's between 0 and 1, so a fraction or a decimal, that's going to be a shrink. So this is a stretch. So then on number 2, we have g of x equals f of negative x minus 1 minus 7. So again, horizontal shift, we're looking inside parentheses. And here it has minus 1. Again, it's the opposite of what it seems like it should be. So a negative 1 is going to tell us to go right 1. Reflection, again, we're looking for a negative. We do have a negative, and this time it's attached to the x, so that means it's a y-axis reflection. Vertical shift, again, we're looking for something being added or subtracted, not inside of the parentheses. So this negative 7 tells us it's going down 7. And then dilation, again, we're looking for a coefficient. There's no coefficient out in front, so that is going to be none. So then on numbers 3 and 4, we are given a function and we are given a graph, and we are just trying to perform these transformations on the graph that we're given. So before we do that, I'm going to write this HRVD off to the side, and we're going to do exactly what we just did in 1 and 2. The only difference here is that we're actually going to graph it after we do that. So again, horizontal shift, we're looking for something being added or subtracted inside of parentheses. So that is going to be none. Reflection, we are looking for a negative. There's no negative out in front, no negative on the x, so that's also none. Vertical shift, we have this plus 1 outside of parentheses, so that's going to go up 1. And then last dilation, we're looking at the coefficient, so this 2 tells us that it's going to be a stretch. So now I'm going to actually use this information to get my new graph, my graph of g of x. So the one that we are given is f of x. We are making the graph of g of x. So I'm going to go to the y-intercept here at 0, 0, and I'm just going to move this point around first. So I don't have a horizontal shift, so I don't need to do that. There's no reflection, so I don't need to do that. So all I need to do is move this point up 1. The stretch isn't going to affect the point, so this is going to be my final point here. So I know a stretch is going to stretch it vertically, so it's going to make it more narrow. So to graph that, I'm just going to take this graph we had and sketch that just a little more narrow than it was. And that is it. So for number 4, I'm going to do the same thing. Before I graph it, I'm going to write HRVD off to the side. And remember, when you're doing HRVD, you need to make sure you are going in that order. Start with H, then R, then B, then D. So horizontal shifts, I'm looking inside of parentheses. And here I have that +3. Remember, it's the opposite of what it seems like it should be. So +3 is going to tell us to go left 3. Reflection, we're looking for a negative. We have this negative in front of the F out here. So that is not attached to the X. That means it's an X-axis reflection. And then V are vertical shifts. There's nothing being added or subtracted out here, so that is going to be none. And then same with dilation. Remember, we're looking for a coefficient out in front. There's no number out here, so that is also none. So then to graph this, I want to go up to the top and start with going left 3. Again, I'm going to go to my y-intercepting, move from there. So move 1, 2, 3, and put our point. And then I need to reflect it across the x-axis. So remember, that's basically going to flip it upside down. It was opening up. Now I'm just going to flip it upside down so it's opening down. And that's it. Don't forget to label your final graph as g of x. And then the last one, number 5, we're doing the same thing. We just have to put both graphs on the coordinate plane this time. So last time we were given one graph. Now we have to make the first graph and the transformed graph. So our two functions are f of x equals x plus 1 and g of x equals f of x plus 2. For f of x equals x plus 1, that's just a regular linear function. So to put that on the graph, I'm just going to identify my slope and y-intercept and graph it like a regular line. So my slope is the coefficient for x, which here is just 1. So I'm going to put that as 1 over 1. And my y-intercept is the number that's being added to that. So it's not attached to x, it's just the regular number, which here is also just 1. So to graph that, I'll put a point at +1 because that is my b value or my y-intercept. And then I'll finish up that graph by doing rise over run. So up 1, over 1, and then just connect your points. So that's all we need to do for f of x. Don't forget to label it. So then when we get to g of x, this is where we need to do the transformations. So we're going to do HRVD. And then fill in those transformations. So there's nothing being added or subtracted inside parentheses, so horizontal shift is going to be none. I don't have any negatives, so that reflection is also none. Vertical shift, I have this +2 at the end, so that means this is going up 2. And then dilation, there's no coefficient out in front, so that is also going to be none. So to do this transformation, I am going to start at my y-intercept, There's no horizontal shift, no reflection, so I'm going to move the point up 2, and then that's it. So from that point, I'm just going to sketch the same line. The only difference is that it moved up 2. And then again, don't forget to label that as g of x. And that's it.